Hello everyone, my name is Saurabh Singh and today I am going to teach about the specific gravity of soil. This is very important topic of geotechnical engineering as you can see here, and this is my lecture number 7, and this is my details is also given here. After watching this video you can call mine on this number 7014914312, and you can also write an email on saurabh.singh@mygyanvihar.com. First, come on the learning objective. To know about the specific gravity of soil, today we will know about the specific gravity of soil, and we also understand what is the oven drying method of a soil. And there is also learning outcome. You will able to learn about the moisture content determination by the oven dry method, and you will also understand the method of determining the specific gravity of soil. This is very important test which we perform in the geotechnical engineering. So let's come on next slide. As you can see here, table content, this is your table content. Determine water content by the oven drying method. And second one, we will see seven-lashes test of a soil. Third one, we will see determination of maximum dry density and moisture content by the modifying Proctor test. And fourth one is to find the specific gravity of soil. And these are the very important topic in the geotechnical engineering. If you will watch this video, you will understand how to determine the water content of a soil, and you will also know what is the dry density and modified Proctor test and specific gravity of soil. First experiment, we will see determination of specific gravity of soil. First, you should also know what is the specific gravity. If anything you will find, if you will find the specific gravity of any material, then any substance, then you have to take the ratio of between density of substance to the density of a liquid at its standard temperature. Means you have to take the density of substance, which you can say so by the gamma, and what will be the specific gravity of, you can say, what will be the density of liquid. In liquid we can easily take the water. So come on the definition of this test, we will see. Definition and purpose. Specific gravity is the ratio between density of substance to the density of a liquid standard temperature. As you can see here, formula is given, and density we denote by the GS, as you can see, and it will be equal to gamma liquid upon gamma water. Now come on the next slide, and now we will see what is the application of a determination of specific gravity. Specific gravity of soil is an important property and used to determine void ratio, porosity, and degree of saturation. If density and water content are known, if you know the water content in the soil, you can easily determine the void ratio, porosity, and degree of saturation. Once we will also see void ratio we represent by the E, and porosity we represent by the N, and formula of E is equals to, it will be VV upon Vs, and porosity will be VV upon total V. VV means volume of voids and Vs means volume of solid. Now we will see the apparatus, what kind of apparatus we use to determine the specific gravity of soil. First we use pycnometer. As you can see here, this is the image of pycnometer, and if you will see the cap of pycnometer, it is conical shape, and there will be also one hole on the top, and this will be your glass bottle, and that is your cap, which is in two parts. One is a vertical this type and one is a cap. And we can also determine by the volumetric flux. As you can see, this is a flux of 500 ml in this image. We use this apparatus during the determination of specific gravity of soil. Weighing machine, which we also call balance, it is the used for the taking the weight of all the materials. Like first we take the weight of soil, after that we take the weight of water, and we also take the weight of empty flux or empty picnometer here. This is your vacuum pump. This is also used to determination of specific gravity. And this is your flux. As you can see on the image, it is the capacity of this flux is 500 mm. Now, what is the procedure? Procedure is very important in the determination of specific gravity. Determine and record the weight of a clean picnometer. First, what you have to do, you have to take your picnometer here, like this. Picnometer will be like in this shape. What you have to do, you have to take the weight of this by the using of weighing machine. You will take the weight of it and you have to record it like M1. And second step will be take the dry soil sample, pass through this sieve number 4 in the picnometer and determine the weight of picnometer by the containing dry soil, and you will denote as the M2. What you have to do, you have to take this soil sample. Suppose this is your soil sample, and this should be passed through the sieve number 4. Sieve means IS sieve. It should be passed through the IS sieve number 4, and after that you have to take the weight of it. Like you can take the weight to 150 gram. You have to take the weight of it. Now what you have to do, add distilled water to fill about the half to 3/4 of the picnometer soak sample for 10 minutes. You have to fill soil in your picnometer. When you will fill the soil in the picnometer, you have to also add the water here, and you have to keep it for the 10 minutes. As mentioned here, you have to keep it for the 10 minutes in your geotech lab also. And your temperature should be normal, like it will keep, you have to keep these flask for in room temperature. Now what will be the fourth step? Fourth step will be apply the partial vacuum to contain the 10 inches to remove the entrapped air. You have to remove the entrapped air by the picnometer. Now what will be the fifth stage? As you can see here, fill the picnometer with distilled water to mark and determine the weight of picnometer and its content. You have to do like this and you will determine the specific gravity of soil. And next step will be increase the picnometer and then fill with the distilled water up to the mark and determine the weight of picnometer and distilled water M4. You have to represent it by the M4. Now here is formula given. Formula is GS is equals to M2 minus M1 upon M2 minus N1, M1 minus M3 minus M4. And you have to put your value in this formula, and after this formula, after putting data in this formula, you can easily determine the specific gravity of soil. There is also results is given how you will find the range of these soil. Like if your sand will be here, like then you will get the specific gravity 0.63 to 0.67. If there will be silt, you will get 2.65 to 2.70. If there will be clay or silt clay, you will get it from 2.60 to 2.90. And the result thus obtained from the above experiment can help us to determine the type of soil. Now we will see one animated video, and by watching this video you will get the idea how to perform this test in the lab. Now we will determine the specific gravity of a cement. We will also see how to determine the specific gravity of cement. And here, weight of volume of material upon weight of volume of water. This is your, and it will be same as a cement. Now we will see the steps of doing by the Lee-Chatterjee method, and it is given in the IS code specific gravity test 2720 in part 3. Now we will see what kind of apparatus we are going to use to determination of. And second, we will use the kerosene. Third, we will use the specific gravity bottle. And these four equipments are very important to determine the specific gravity of soil or determine the specific gravity of a cement. Now we will see the procedure, this sequence. We will see by this video. First, we have to do. First, what you have to do? First, we have to weigh the empty flask and note as W1 as. After that, we have to take the 50 gram of cement or soil and add into the flask. And note on your left side, this is your flask plus 50 gram of cement. Now, what you have to do? Now you have to pour kerosene in this sample up to the neck of the bottle air bubble left in the flask. Note down the weight as W3. As you can see here, we will note down the W3 and 50 gram of cement plus kerosene. It will be recorded as W3. And now we will see the fourth step. What will be our fourth step or cement? Fourth step will be empty the flasks. We have to remove all the bottle with the kerosene up to the tip of the bottle and record the weight as the W4. As now in flasks plus kerosene is equal to W4 things from the bottle. And here you can see W1 is weight of empty flask, W2 is equal to plus cement plus kerosene, W4 is equal to weight of flask plus kerosene. And these are the procedure, and there is only 4 steps which you have to perform in the geotech lab. And by doing this test, you can easily find the specific gravity of soil. And here is a formula is also given, which is W2 means weight of empty flask, and W3 is equal to, as you can see here, weight of flask plus cement plus kerosene on the cement. On the place of cement, there also can be soil, and W4 will be weight of flask plus kerosene. And one more thing is very important here to know. On the place of kerosene, we can also use the water, and we have to take the specific gravity of water here on the place of kerosene. Now we will see the seven-lasses of soil. As you can see, this is your second method to determine the seven-lasses. Determine the size of soil by the analysis of sieve. And here you can see this is 2 mm sieve, which is gravel, and 4 number sieve, which is for use for the sand, and this is 200 mm sieve, which is used for the fine. Now, as you can see here, there is sieve, IS sieve, and it is made by the brass. If you will see the size of this hole or shape of this hole, it will be rectangular. In many exams, this types of question have been asked. What is the shape of these? What is the shape of these holes of these sieve? Then you have to answer it here. It is rectangular, or you can also call it this is square. Now come on the next, and sieve disintegration. What is the sieve disintegration? Sieve larger than 4 mm sieve was designated by the size of the opening in the sieve. As you can see, this is the size of this sieve is 4 mm. Now, you will also see the sieve designation for the smaller. As you can see, small sieve are numbered according to the number of opening per inch. As you can see, this is your 10 mm sieve, and there is opening per inch is 1. Now, what will be the procedure of sieve analysis? First, we will see here First, we have to write down the weight of each sieve as well as the bottom pan to be used in the analysis. Second, record the weight of given rice file sample. Third, we have to make sure that all the sieve are clean and assemble them into the ascending order of sieve number 4, sieve at top, 200 mm sieve at the bottom. Place the pan below the 200 mm sieve. Carefully pour the soil sample into the top of the sieve and place the cap of the it. Fourth procedure will be place the sieve stack in the mechanical shaker and shake it for the 10 minutes. Fifth will be remove the stack from the shaker and carefully weigh and record the weight of each sieve with its retained soil. In addition, remember the weight and record the weight of bottom pan with the retained fine soil. Now you can see the figure how we will arrange this sieve, and in the bottom there will be a pan. As you can see here, that is your pan and this is your balance. And pan will, what will happen in pan after doing, after passing the soil, the fine particle will go in the pan, and after that what we have to do, we have to do the weight of each sieve one by one, and then we will get the weight of each soil. Like there is fine soil, there is coarse soil, there is clay soil, silt. We have to take the weight one by one. Now, as you can see here, there we are doing the sieve analysis. It is now on the sieve shaker. As you can see, this is your sieve shaker on which we put all the sieve together with the proper arrangement. Then we shake it till the 15 minute. In 15 minutes, what will happen? It will pass through the all the sieve. Soil will pass through the all sieve. If the size of soil will be bigger, then it will be retained in the sieve. And then we have to do the weight. Now we will see the data analysis, how we will do the data analysis of these things. And first you can see here, obtain the mass of the soil retained on each sieve by the subtracting the weight of empty sieve from the mass of the sieve plus retained soil, and record this mass as the weight retained on the data sheet. The sum of these retained mass should be approximately equal to the initial mass of the soil sample. A loss of more than 2% is the unsatisfactory. Calculate the percentage of retained on each sieve by dividing the weight of retained on each sieve by the original sample mass. Now calculate the percentage passing or percentage finer by the starting with the 100 percentage and subtracting and the percentage retained on each sieve as the cumulative procedure. Now this will be our graph here. As you can see, we will easily can plot the graph by the weighing of this soil. Now, as you can see here, this is the test result. Example, if you will see the number sieve, it is 4, 10, 20, 40, 60, 140, 200 and pan. And if you will see the mass in the pan, there is also some mass in the pan. You can see here, we are getting some soil in also pan. For example, we will see it, we will understand it by the example. If you will see the example of it, you will see total mass is equals to 50 gram. We are taking the total mass 50 gram. Mass retained on sieve number 4 is 0.97, means 97 gram will retain by this sieve number 4. For the number 4 sieve, quantity passing is equals to total mass minus retained. How much it will be retained, you will see here. You can see we are getting it after passing 9.7 gram, we are getting here 490.3 gram. The percentage of retained is calculated at percentage mass retained upon the total volume. It will be 9.7, which is passed, which is retained by the number of 4 sieve is equals to total mass. Total mass we taken here 500 gram, as you can see here, into 100. Then we are getting it 1.9%. From this percentage of passing is equals to 100 minus 1.9. It will become 98.1, means 98.1% soil are passing through the sieve number 4. Now we will see the grain distribution. As you can see, this graph is showing the grain distribution. Unified soil classification, we will do it also in other class. Now we will see the MCQ related to geotechnical engineering. Next point we will see the Proctor test. First, we need to know what is the Proctor test. As you can see here, compaction of soil is the process of applying energy to loose soil to consolidate it and remove any voids, thereby increasing in density. Consequently, it is load-bearing capacity. The Proctor compaction test is a laboratory method of experimentally determining the optimal moisture content at which the soil sample type become most dense and the achievement is maximum density. Means Proctor test we do just to achieve the maximum dry density of a soil. How we do it? There is all procedure, and by this procedure we find the optimum moisture content, means how much amount of water we need to add in our soil sample so that soil can give the maximum dry density. And this will be your water will be added in soil, and we will determine the on which quantity this soil will give the maximum density. That is your motive of doing Proctor test. Now, as you can see, the Proctor compaction test, the purpose of Proctor test. The Proctor compaction test is a laboratory geotechnical testing method used to determine the soil compaction properties, especially to determine the optimal water content by which soil can reach in the maximum dry density. As I told you earlier, means we need to find the optimum moisture content, as it mentioned here, optimum moisture content to reach at the maximum dry density. These two terms are very important. One is optimum water content and second one is dry density. Okay, now we will see how we will perform this test. First, as you can see, compaction test. Compaction is essential to many geotechnical applications to improve the engineering properties of soil. Proctor 1933 proposed a compaction test which gives the MMD, means maximum dry density, and OMC, means optimum moisture content. These two terms is written in the short form. MDD means maximum dry density, OMC means optimum moisture content, known as the Proctor compaction test. The Proctor compaction test is easy to perform in the laboratory due to the workability of sample equipment. Here we will see the standard Proctor test, what kind of equipment and what is the method of doing standard Proctor test. The standard was originally developed to simulate the field compaction in the lab. Purpose: to find the optimum moisture content at which the maximum dry unit weight is attained. What kind of equipment you will use? Standard Proctor test. First, we will use the mold, hammer, drop, 3 layer of soil and 25 kilos per layer. That will be your mold, and each layer will be compacted 25 times. This is a very important point which you need to remember it. Now this is the equipment. And as you can see, apparatus, and this is your hammer. As you can see in the figure, this is your hammer, and the weight of hammer is 0.26 kg. This is very important to know. And there is drop distance. It is from 310, and modified in standard it is from 310, and in modified test it is from 450 mm. And same hammer will use in standard Proctor test and as well as in modified Proctor test. And this is your mold. As you can see, the size of mold, and you can also say diameter of mold is 100 mm, and this will be approx 1000 also. Okay, and this is your Proctor mold, and first soil layer will be filled, second soil layer, after that third soil layer, and each soil layer you have to compact 25 times. Now, as you can see, number of blows is given here, 25. Drop will be from, as you can see, drop will be equal to 304.8 mm, and it is approximately 12 inch. Weight of hammer is also given here, which is 2.5 kg, and mass, if you will calculate the mass of that hammer, it will be equal to 5.5 lb. As you can see, soil will be placed in this manner: first layer 1, second layer, third layer, and the size of mold and height of mold will be 116.43 mm. Now we will see the procedure. What will be the procedure? First, as you can see, either mix 4 kg of sand and 400 kg of bentonite or soil as per mixed about the 4.5 kg, break any lumps. Add water about 0.5% of the sample. Suppose your weight of water, suppose weight of sample is 1 kg, then we have to use the soil sample. 9.5% of this means 9.5 ml water we have to use. And as given by the instruction in the mixology, until all the water uniformly absorbed. Third procedure will be weight the empty mold without the collar or base and record the mass. In fourth, with the collar attach the mold compact specimen in 3 equal layers and get the total compacted depth of about 130 mm with 25 uniformly distributed blow of hammer per layer. During the compaction, mold should be rest directly on the concrete floor of the lab, not in the mixing pan. Remove the collar from the mold and strike of the soil with the straight edge even with the top of the mold. Weigh the mold, the sample, and record their mass. Subtract the mass from the mold from specimen and multiply by the 1060 and record the result as the weight density of the compacted specimen in the kilogram per meter cube. What will be your sixth step? Remove the soil sample from mold using the airport press. Obtain the moisture content sample about the 120 gram from the center of the specimen. Wait and the place oven in the oven to dry. Now it will be your last procedure. Now we will see the modified Proctor test. What we have to do here. That was your standard Proctor test, and now we will see the modified Proctor test. It will be in modified Proctor test, equipment will be same as you can see here, and the modified was developed to simulate larger compaction effect for the more serious loads and bigger equipments. Means we determine the optimum moisture content for the sample here for the more load. Now this is your equipment for modified Proctor test. As you can see, this is your collar here. That is your collar. We have to remove before the filling this file, and this is your hammer, and we have to fill this mold in 3 layers. first layer, second layer, and third layer. And then we have to fill the, we have to put the color on it. Now we will see the procedure of modified Proctor test. It is similar to standard Proctor test, but we will see the procedure of modified Proctor test also. Take 6,000 gram of sand and mix with the 6 gram of bentonite or pre-mixed soil available about the 6.5 kg. About 7% of water as sample given by the instructor to mix thoroughly until the all water is uniformly absorbed. Wedge the empty mold without the collar or base and record its mass. Fourth procedure will be with the collar attach the mold, compact the specimen in 5 equal layers and to get the total compacted depth about 130 mm with 55 uniformly distributed blows of primer per layer of the specimen. During the compaction of the mold should be rest directly on the concrete floor. It is same as standard Proctor test. Remove the collar from the mold and strike up the soil with the straight edge. Weigh the mold and soil record their mass. Subtract the mass of mold from the specimen and multiply this mass by the 471 and record the result at the weight density in kg per meter cube of the compacted specimen. Now what we have to do next, remove the soil sample from the mold, obtain the moisture content of sample from the center of the specimen, weigh and the place oven drying method. The moisture content sample should be weight approximately 100 gram. As you can see here, we will take the 100 gram sample and we have to put in the drying oven. This was all about the modified Proctor test. Our first question is given here. Water content is given by, means how you will determine the water content of a soil. It is given weight of water upon mass of soil, mass of water upon mass of solid, mass of water upon mass of soil, and mass of water plus weight of soils. Let's see how we'll represent it. Weight of water means WW and weight of soil WS. Mass of water means M, mass will be represented by the M, and mass of solid means MS. Okay, and mass of water MW upon mass of soil, it is your solid, and it will be your soil. Okay, and mass of water plus mass of solid. Third one is given mass of water plus mass of solid. No, weight of solid is given here, weight of solid. And as you know, what will be your right answer? First, we can determine the water by the in the term of mass. Means your these things will be deleted, this thing will be also removed. And here you can see that can be your right, but this is also not right because we are taking only the soil. And your right answer will be here B. Okay, mass of water upon mass of solid, that will be your right answer here. And now we'll see the explanation. In geotechnical engineering, water content is a very important parameter for analyzing the water. It is expressed as a mass of water divided by the mass of solid, and it denoted by the W and expressed in the percentage. Means we will find it in the percentage. How much percentage of water is available in the soil? That will be your right answer. Now we will see the second question. Who is the father of geotechnical engineering? Now see, and Christian Othomoher, there is answer is given Karl Tajagahi. If you will see, you will see the name of Tajagahi. He has given many formulas and many theories in geotechnical. As we know, Tajagahi is given, he is also given formula for the foundation. He has also given the equation in the permeability. So this is the very important man for the to the in the field of geotechnical engineering. He was an Austrian civil engineer and geologist. He was also geologist. Most of finding in geotechnical engineering and soil properties are done by him. Many times in question, this type of question has been asked. And what was the nationality of Tajavi? It is Austrian, and he have done a lot of work in the field of geotechnical engineering. Now we will see the third question. According to Darcy law, Q is equal to IA, Q is equal to KA, Q is directly proportional to IA, and Q is directly proportional to KA. What is the formula of these things? And here I is the hydraulic gradient, Q is the discharge, and A is the area. And we will see Darcy law states that the rate of flow per unit time proportional to the hydraulic gradient. Okay, and Q is discharge. What is the Q? Q is the discharge of water. You can say per minute, how much discharge in unit of time. If you will calculate it, you can take it in minute. And I is the hydraulic gradient. What is the I? I is the hydraulic gradient. And A is equal to area, total area. Okay, it is asking, according to Darcy law, what will be your right equation? Here answer will be C. Q is directly proportional to hydraulic gradient and area. Your right answer will be here C. C will be right answer. Come on the next question. Triaxial compression test is used to find of soil. Why we conduct the triaxial test? This is also very important question. In many exams, this kind of question have been asked. Here, right answer will be shear strength. We determine the shear strength of soil by the help of triaxial compression test. Here is the explanation. There are four methods available to measure the shear strength. First one is direct shear, triaxial compression test, unconfined compression test, and vein shear test. Triaxial compression test is the most accurate one. If you will see the result precision of triaxial, it is more accurate than all this test, and we determine the shear strength. Here it will be your right answer. Shear strength. Triaxial compression test is used to find the shear strength of soil. Now we will see the next question. Next question is number 5. Index is used to find the settlement of soil. What will be your right answer here? First is given compression, expansion, recompression, and reloading. Here your right answer will be A. A means compression. Here is explanation. A plot is made between void ratio and long effective stress lower. It is shown different curve corresponding to loading and reloading of soil. Compression index is shown by this formula. The right answer here will be compression. Compression index is used to find the settlement of soil. Now come on the sixth question. What will be your sixth question? Which of the following does not happen when compaction is done? Permeability decreases, water content increase, shear strength decrease, compressibility decrease. Here right answer will be shear strength decrease, because when we compact the soil, our permeability will decrease. Means then how permeability will decrease? Means what we are doing in the compaction, we are just removing air bubbles and water bubbles from the soil. If air bubbles and water bubbles will be removed by your soil, what will happen? Permeability of the soil will be decreased. Means water cannot pass through the soil. Simple. When is solved here? Water content increase. Yes, water content can be increased because area of your sample will be reduced due to the compaction of soil. Shear strength decrease. This is not right, because shear strength will also increase of the soil. If you will compact this soil properly, it will not. There will be not shear failure, and compressibility decrease. Next question is, index is used to find settlement of soil. In this question, it is asking what will be the right answer. Your right answer here will be compression. Compression will be your right answer. And come on the next question. Which of the following does not happen when compaction is done? And I think we have done this question. And your right answer here will be C. Shear strength will increase, it will not decrease. And come on the next question. Next question is number 7. Is blank is there is the measure of loss of strength by the remolding with the water content and charge. What will be the right answer? Here is option given: compressibility, sensitivity, stability, and triisotropy. Let's see what will be the right answer. Sensitivity values range from 1 to 16 for intensive soil, and a soil insensitive above 16 is termed as quick. And here right answer will be your D. Come on the next question. Next question is also very important. Geotechnical engineering soil is considered as phase material. Means what will be the phase of soil? As we all know, soil is divided into three part here. I will draw the diagram. First part will be solid. Here it will be solid, and that will be your first phase. And in second phase, it will be air. We can say it, or water. And third stage will be water. Let me explain it clearly by the making of a diagram. Suppose this is your soil sample, and now we have to do what we have to do. We have to make in three phase. First phase is here, second phase is here, and third phase is here. And in first phase there will be solid. What will be here? Here will be solid, and in second phase there will be water, and in this phase there will be air. That's why your soil is called three phase. And in question it is asking, in geotechnical engineering, soil is considered as three phase. Your right answer will be 3 here. And as you know, soil is three phase material and it consists solid, water, and air. It is represented in three phase diagram with the volume or left side of mass of the sample. If you will see here, we will explain it, or we will represent it by the volume of air, by the volume of water, and by the volume of solid. And here we consider it as a volume of weight of air, weight of water will be here, and weight of solid. That will be your right answer. Means here A will be your right answer. Come on the next question. Blank is there. Is measurable. Measure the loss of strength with the remolding with water content unchanged. What will be the right answer here? Here right answer will be your. We have done this question. We will come on the next question. Fine particle are those particles with size less than. We are asking what will be your fine particle. Here is given 0.023, 0.090, 0.075, 4.75. What will be your right answer? As we know, fine particles should pass through the 75 micron sieve. 75 micron sieve, and it will be your ISC micron. It will be your ISC, and here right answer here will be 0.075 mm. If we will convert micron into mm, it will become 0.075 mm. It will be your right answer. Right answer will be 0.075 mm. Come on the last question, which is here. The mass of density of water at 4 degrees Celsius is here 1000 gram per ml, 1 kg per meter cube, 1000 mg per meter cube, 1000 kg per meter cube. What will be your right answer? Right answer is here 1000 kg per meter cube. We consider the density of water at 4 degrees Celsius is 1000 kg per meter cube. The explanation is also here. Mass density is the ratio of mass of water to the volume of water at 4 degrees Celsius. It's 1 gram per ml, or we can also write it 1000 kg per meter cube, and 1 mg per meter cube, we can also write it. Now come on the reference. It is your reference. Here is a NPTEL link, which is very important. If you will watch this link, you will get very good idea about the advanced foundation engineering and advanced geotechnical engineering. And this is a book which I am referring to you all. And this was all about the today class.